Colleen.
Hello, and welcome to another episode of Iron Science Teacher. It's the show where we celebrate great teaching. Imagine that. My name is Julie Yu. I'm a senior scientist here at the Exploratorium, and I will be your host for today's show. We are here at Pier 15 in San Francisco at the Exploratorium, and we are also broadcasting live online to potentially millions of people, or 20. Iron Science Teacher is a show we do here. It's based on the Japanese cooking show Iron Chef. Here we also have a secret ingredient, but that secret ingredient is for teachers to use to construct a science demonstration or activity to share with you all. All of the contestants today are participants in the Teacher Institute's 3-week summer institute. So they have been here at the Exploratorium working with us for 3 weeks to improve science learning in classrooms around the world. Are you guys ready to meet them? Okay. First up, we have taking the high school physical science class. Please welcome Derek Coleman. Derek, can you share where and what you teach?
I am a physics teacher at Lighthouse Community High School in Oakland.
Welcome, Derek. Next up, taking the middle school institute, please welcome Jenny Hartigan. Good sportsmanship. Jenny, can you share where and what you teach?
I am Jenny Hartigan, and I teach middle school science, mostly 8th grade, in Alameda, California.
Great. Welcome, Jenny. All right, third up, taking our Life Science High School Institute. Please give a round of applause for Colleen O'Rourke. Come on down here. Colleen, can you share where and what you teach?
I teach biology here in San Francisco at Archbishop Reardon High School.
Great, welcome, Colleen. And last but not least, also taking the Middle School Science Institute, please welcome Allie Graham. Allie, come on down here and tell folks where and what you teach.
I teach 6th grade math and science at Creative Arts Charter School here in the city.
Great, welcome to all of our contestants. There is one more introduction to make, and that is the introduction of our secret ingredient. So the secret ingredient today is packing material. We have all this packing material. All right, thank you. Thanks, Kim. All right, third up, please say hello to Colleen O'Rourke.
All right, so as I mentioned, I teach high school biology, and biology is my favorite subject. When I was in elementary school, middle school, high school, all my favorite classes were biology. My undergrad, I majored in biology. I went on to get a master's in biology. I've done research internships with biology, so I really love biology. And today, I'm going to talk about physics. So, in high school, as well as taking biology, I also took physics, as many do. Mr. Gibbons, Foothill High School in Pleasanton. And one of the things that he really hounded into us in physics, when you don't know what's happening, frequently the explanation comes down to this concept, which is surface area. So it was to the point where he was constantly all year, like surface area, that if we had a test, and we didn't know the answer, if we just wrote down surface area, 9 times out of 10, he'd still give us a point. So, I've gone on in biology, obviously not physics, but what I have found is that surface area seems to explain a lot of things that happen in biology as well. So, first, before we get to that, I wanted to talk a little bit about what surface area is. By its name, surface area is what? The area of the surface. Well, in biology, one thing that's really important is the idea of surface area to volume ratio. And what is volume? The space, the stuff in between, right. And frequently, what do we usually fill volumes with when we're packing packages? Peanuts, good. So, what I have done here is come up with some little demonstrations, because when we're working with numbers, I'm a scientist, and we don't really work with numbers frequently. So instead of working with numbers, I have some visuals to help illustrate this. So this box here we've got the surface area of the box is covered in packing peanuts. And if I was packaging something to ship it, I would obviously fill the volume of it with packing peanuts as well. In a larger box, we also have a surface covered in packing peanuts, and we would fill the middle with packing peanuts as well. Now, one thing you may notice, these boxes are different sizes, and clearly, when we go up to a larger size box, we're going to have more surface area. But what people don't realize is that the ratio of the surface area to this box to whatever is in the middle is different than the ratio of the surface area to this box to the volume in the middle. And to illustrate that, I counted out, one by one, these small, oops, wrong bag. In this small box, the volume of it is represented by this amount of packing peanuts, and the surface area is represented by this amount of packing peanuts. So you can see they're pretty equal. In fact, actually, the surface area is a little bit larger in packing peanuts than the volume. But the larger box, here we have the packing peanuts of the surface area, and these are the packing peanuts of the volume. So you can see we have gone up in size in the surface area, clearly, but the difference between the surface area to the volume is much different in the larger box than in the smaller box. So how does that relate to biology? Well, in our bodies, what is our surface area? Our skin covers our surface area, and things pass in and out of our skin, especially body heat is frequently or constantly radiating out. So if you took myself and one of our young scientists here and dropped us in the middle of the snow, which one of us would start to shiver first? The young scientists, because by being smaller, they have less volume and more surface area, so they're going to radiate heat faster than me, who has more surface area, but the larger volume, I'm going to constrain that heat much more effectively. And that's frequently why we see many animals that live in colder regions tend to be larger, because it's more efficient. Does that make sense? Good, because now I'm going to test you on it. Just like in high school, I have a number of questions here. You can consider this a pop quiz, partially because you weren't expecting it, but also partially because for every answer you get right, I'm going to pop a poly airfill bag here. Not quite as dramatic as a water balloon, but we'll do it. Or a watermelon, but we'll do it. Now, spoiler alert, you probably already know what the answers to all these questions are. So, all right. Yeah, wait, hold up. We're getting there. All right, first off. Okay. Ears. We see many animals that have really large ears. What does that usually mean? They got more surface area. It means they can hear things. So, larger ears, you can absorb more mechanical wavelengths of the sound. So, better hearing comes from better surface area. Excellent. Woo. Nice. Eyes. So our eyes absorb photons of light. They hit retinas or cells on the back of our retina. And we frequently see nocturnal animals tend to have really large eyes for their body size. Like owls seem like they're half eyes. That is because if you have a larger eye, you're going to have a larger retina, means you're going to absorb more light because of larger surface area. Excellent. So far we're getting a passing grade here. Similar to eyes absorbing light, leaves absorb light as well to do what? Photosynthesis. Good. If you take two plants that are from the same species and you plant one in an area where it's sunny and one in an area where it's shady, the plant growing in the shade will start to grow larger leaves than the one growing in the sun. And that is because it's trying to make up for the less amount of light by growing a larger surface area. Getting into anatomy, following up on our nerves discussion, our lungs absorb air. Obviously, we take in oxygen, we exhale carbon dioxide, but it's not just a balloon. There's all these little pockets called alveoli that help pull in the oxygen and excrete the carbon dioxide into our bloodstream. Having all these itty-bitty little pockets instead of one big bag increases the surface area. Last one. So, elephants. You might be thinking to yourself, I mentioned, hey, larger animals tend to stay warmer where it's colder, but elephants are the largest animals on Earth, and they live where it's really, really hot. So what gives there? Well, if you want to vent heat, obviously, you might want to increase your surface area. So what do elephants do? Their ears, by flapping them out, helps increase their surface area. Wait, I'm not sure what that one was. Can you? Surface area. One more time. A couple people didn't get it. Surface area.
Woo! All right. Let's hear for Colleen O'Rourke, who packed it in with the physics and biology of surface area and volume. Thanks, Colleen.